Okay, thank you very much. Yes, my name is Bernd Lapp. I'm in the crypto space since 2014. I came to live in Switzerland from Germany and eventually worked for a mobile banking startup, and that's where I learned about blockchain. So, and I'm lucky that I moved to Zug when I came from Germany by coincidence, and now I'm in the middle of Crypto Valley and working on blockchain topics. I have my own blockchain startup, or I work with a group of people on a project, and then also part of this presentation. So, yeah, I look forward to presenting it to you. And first of all, I'm not a blockchain expert, okay? So don't expect anything technical from my side. And I don't think I understand, or I think I understand maybe 10% of what a blockchain is. And in my opinion, there's maybe only 4 people in the world that really understand the blockchain. One of them is called Satoshi Nakamoto, and we don't know who he is. So anybody that claims he's a blockchain expert, he should be maybe a relative of Satoshi Nakamoto. But I will explain to you what I know, and hopefully this will be beneficial to you. It is also demystifying a bit about blockchain. Because sometimes people say blockchain, we can use it for this and we can use it for that, and this is great, this is the best technology ever. I will show you that we're very early stage. I'm not going deeper into that. But again, I don't think you have to understand blockchain technically, but you should be able to use it. So for example, I don't understand the internet. I don't know how the internet works. But I'm using email, I'm using LinkedIn, even telephone calls are over voice over IP. So it's also using the internet. I think everyone today has used the internet, but I'm not sure if all of you know how it works. So I want to show you later on how products can work on a blockchain without you having to know what a blockchain in detail is. But you should learn the basic principles of a blockchain, because if you use blockchain technology, you have to be aware that it's very self-sovereign. You have to be very self-sovereign. You cannot rely on a third party, because this is what a blockchain is about. It's eliminating a third party that keeps the trust in the system. It's the technology keeps the trust in the system. So, why is blockchain early stage? And I say it's very, very early stage. So if we compare it to the internet, and I said before, I think everybody uses the internet today, but do you know when the internet sort of started? Anybody has any clue? When was the internet, when was the first time that 2 computers that were not directly connected communicated? Before the 70s. Yes, very good. So it's
I get a coin?
Airdrop, whatever. So it's 1969 is the DARPANET, it was called. I have to look it up what the name exactly is. It's a Defense Advanced Research Projects Agency. So it was a military solution that was created. And in 1969, they communicated within 2 computers, and the first word that was communicated was login, and then the system broke down. That was it. But it was enough proof that this communication could work. So that was 1969. Then the next step was that a protocol was being created that computers can easily communicate. It was in 1974, around that. Then what we know is the internet actually came to life in 1989. That is when Tim Berners-Lee invented the World Wide Web, the way that we can use the web. You know, we don't have to program in opcode and communicate, but we can actually use a browser sort of thing. So it was 1989. And then we had the dot-com bubble really quickly after, or not quickly, but coming after that. So that was where things got hyped and everything imploded. Yeah, and then we had things like Facebook come in 2006, I think, or 4 maybe. That was when Facebook was alive. So it's 14 years ago. Facebook is already 14 years old. Yeah. Quite interesting. And this is where Bitcoin came to life. 2008, 2009. 2008 there was a white paper written, and 2009 was the first time that somebody did something with that. So it's not that long ago. And then the latest, or one of the interesting versions of a blockchain is Ethereum, for example, came to life in 2014, and the first time that they were actually useful and usable was 2015. So that's 3 years ago. So overall, if we look at the internet, it took like 40 years before Bitcoin or a blockchain was created on top of the internet, because a blockchain only works on the internet to be able to communicate. So the internet is necessary for having that. So that's why I'm saying we're early stage, because right now we're 10 years, Bitcoin is 10 years old. But we already expect so many things from it. And Ethereum is just 4 years old, maybe 3 years, actually. So, and we expect a lot of things of it. But if you see from the 1989 to 2006 or more, when Facebook came to life, it takes a while until products really get to come to be able to be used by mass or have mass adoption. Well, let's go into a blockchain, and let's look at the inefficiencies of a blockchain. So if you look at a blockchain and want to store data, like you can do on your home computer, if you would use the blockchain today, the Ethereum blockchain, and store data, if you compare this to a 250 gigabyte hard disk, yeah, or SSD. This costs like $75 maybe, the hard disk. If you would store the same amount in a blockchain, it would cost you the amazing amount of 120 million US dollars. I don't know if the concept of gas was being explained this morning.
I think it's good to touch on that.
Okay, so why does it cost that much money? Because every transaction has a transaction fee, or there's a cost involved for people to transact this, for the sort of the miners and everybody involved to transact this. Especially in the Ethereum blockchain, because the Ethereum blockchain is Turing complete. Turing complete means a program can run infinitely. So it can be programmed so that it runs and runs and runs and runs. And this is an attack vector. So you could attack the Ethereum blockchain if you create a very big processing program that uses a lot of processing power, and you would deploy this into the blockchain, and it would run forever, and nobody could use the blockchain because this takes up all the energy of the blockchain. So the idea was to prevent this attack vector, was to integrate a cost for transactions, for processing power. And this is called gas. It's like your car needs gas. It's the same principle. So if you drive from Zug to, I don't know, Munich, then you need a certain amount of gas to get there. And if you run out of gas, you cannot go further. And it's the same with the processing power here in Ethereum. So you pay for the processing power to get to a certain result. And the transaction needs gas to transfer value, for example, or to store data. So this is the principle. And if you use this gas, the cost for the gas, then it comes up to this huge and insane amount of money that you would need to store data. So blockchain is not really useful to store data. That's sort of the basic concept here. Then, but look at the information of the processing power. I said you can use it as a processing power. But if you look at what the cost for processing power would be, if you buy processing power on, I think this is Amazon, the Amazon service, it's about, yeah, what does it say, $1 cent, maybe a bit more, the way if you sort of increase the power. But if you want to have processing power in the Ethereum blockchain, equivalent to a service like Amazon offers it, it would also cost you a lot of money. That's $4,000, almost $5,000 per hour of processing power, which actually costs just maybe the highest is 10 cents if you're using the largest package with the 64-bit platform. So again, this is not, blockchain is not very efficient. It's very inefficient right now. But, so the question is, why do people like blockchains? Why is this hype about blockchains? Why is this so, the greatest thing since sliced bread? You know, why is it so great? So, anybody can tell me, why is a blockchain great? I mean, why do you want to use it if it's so inefficient? It's hard to determine that. So the reason is, if it's done right, and I mean by done right, I mean a public blockchain that is available for anyone to interact with, that is not owned by a central party, that is not, cannot be maliciously abused, so to speak, that anybody can work with. And anybody can validate blocks. That is when it comes, what makes it so interesting. Because then it minimizes, for example, trust. It is censorship resistant. I think you probably talked about it this morning. So these are the topics that are really interesting, why a blockchain is so interesting. It is fraud resistant. So it's almost tamper proof, or tamper resistant. I say almost because there is an attack vector. It's called the 51% attack. So if you have nodes in a network and you're able to sort of collude with more than 51% of the nodes, or you actually have hashing power, I won't go too deep into this topic now, but just want to explain it. If you have enough computational power to sort of manipulate 51% or own 51% of the nodes, of the hashing power of the nodes, then you can manipulate the content in the blockchain. But the cost for that is always higher than the result that you will get. Because what can you do in a blockchain? You can manipulate a currency. You can sort of double spend. That is the attack vector you can do in a blockchain. So if a miner would sort of use a transaction and sort of mine a transaction and use it again for another spending, the same transaction, if he has enough computational power, he can do this. Then he would sort of mine more tokens, or he would spend more tokens than actually are in the system. This happened just a few weeks ago to a coin called Bitcoin Gold. And usually what happens to this token, because it's visible, everybody can see what's happening in the network. So once this gets visible, the price of the token will drop immediately. Because now people see that it's been attacked, it's been abused, and somebody has abused the system. So people will not pay the same price for the token again. But the attack itself costs a lot of computational power, a lot of energy, a lot of hardware even. So the cost for that is every time it's higher than the benefit you will get from having more tokens, because the token price will drop.
Can you just ask this question? Why do you say minimizes trust? It should be maximizing, right?
No, it's trust in you. If we do a deal together, I don't have to trust you. It minimizes the trust because I trust the system.
Minimizes the trust
Between two parties interacting.
All right.
Okay, but it's a good question. I mean, you could also say it maximizes trust because I don't have to put in any trust.
It's a no-brainer, right? I mean, it's basically.
Yeah.
That's why it's called trustless, which kind of seems counterintuitive.
Yeah, but it's a good question. So then, if it's decentralized, it's also robust because it's redundant. You have a system that is redundant. So if one node breaks down, there's many other nodes that pick up the same volume or the same information. And if it's public, it also means it's interoperable. So if I write a smart contract on a public blockchain, then anyone can interact with that. he doesn't have to ask for permission. So it's therefore it's interoperable. I can interoperate with any smart contract that is deployed on a public blockchain. There's nobody I have to ask for permission to do this.
So, well then, on a small scale private blockchain, how many of those points are relevant?
I would say maybe robust.
Certain redundancy.
Exactly, it has more redundancy. The other ones, you have to trust the parties that have the power. It's not public anymore. It's not anyone can sort of run a node because you have to have permission. So to me, that's much more closer to a database today. And if I looked at the inefficiencies, then I would say use a database because a private blockchain really is too inefficient to be run. So it's actually more database. Now let's look at what this could be for a business today. So if we run a business today, usually we have a core problem that we solve. So there's something that we are good at solving. A bank, it's good at storing the value, for example. Or it's, what else? What other business could be there? Like, I'll go into Uber on the next slide. Uber is great at connecting drivers to passengers. So they give, I want to get to a certain point and I need cars that are available real quick. And Uber is great at giving me a quick car, sort of availability. So there's a core problem that a business should solve, otherwise you probably don't have any customers. Then you need administration to run that. So if you have any staff, you need HR, whatever. Then you need finance. Somebody needs to take care of the finance, needs to do bookkeeping. Then you have a business model that needs to be maybe adjusted sometimes. You have to run it, the revenue comes from that. Then maybe you have investors that have been participating in your company just to get it started. You have to deal with those stakeholders. Then you have to definitely communicate about your product. So you have to get market or invest into marketing. You have people that do that, and so on. So it's a lot of things come to play just to solve this core problem, just to be the company that solves this core problem. And so what if we could outsource most of this work? So we don't have to do all the things ourselves, but we can really focus on the core problem. This would mean we, from a generalist as today, so every company has to be a generalist. They have to solve the core problem, they have to administrate, they have to do finance, they have to do all these things. And they're not specialists in each of this area. Especially in communication and marketing. Those are areas that not every company is a specialist in. They have to do it, definitely. And they create like their own departments in there. But if we could outsource this, it could be like this. And this is where the blockchain is interesting. So we still solve the core problem. Now we have like the administration or even the business model can be integrated into smart contracts. So this is an automation process now. Now we can automate things. We have the finance is done by cryptocurrencies because now we have a token that is sort of taking care of the finance part, and we even have a ledger, which is the blockchain itself, which tracks all the ins and outs of our currency. Then we have the token function is the business model actually. So we define what is the function of the token. And don't forget, the token itself is a business model. So if a token is created, the token economics, usually what products do is they have a deflationary model. So they cap the amount of tokens that they create. Not every blockchain does that, but it's an interesting mechanism. Because what this does is that it increases the value of the token the more it gets used. So this is a business model itself. It creates revenue because if you hold the token early and you have it over a longer time, you have a bigger return of investment. That's why a lot of people speculate on tokens today. Then you have the token holders, which is actually your community as well, and they will promote your product. They probably also benefit of promoting your product because they participate in your business model. And they're investors. They're like the, as I said on the slide before, I can show it again. No, this is the wrong one. Sorry, wrong button. So I talked about investor relations. So every token holder is the people I actually now have to talk to and convince that I'm doing the right things. And they will give me feedback as well. And if I do it right, if I even have my product open source, these token holders might also invest their time and skills into my product. They might build the product with me. So it's increasing the power of the product. Communications and marketing is something that the community will do because they see the benefit, probably their token holders as well, or they participate in the business model itself. So they will support your model as well. So it's less effort on these peripheral topics and more effort on the core product that can be done. You can have much more specialists involved, and you can focus on your core problem that you're solving if you run it on a blockchain. So this is one thing. So, but to summarize this, so the blockchain minimizes trust between parties. And it's, as I said before, or just in the slide before, is you can automate a lot of processes. So it makes things easier, and you outsource actually your skill set. But on the other side, decentralization is not easy. Because if you want everybody to be able to participate, the consensus or the rules that you set for the system have to be very solid. And that's why right now, blockchains are mostly not scalable if they're public. Because it's really, really hard to scale a blockchain that is public because it's open to anyone. Anyone should be able to participate. And this needs, for security reasons, this makes it much slower than if you just say, you, and you can run the nodes. And between the three of you, we have a very light consensus mechanism, and I can always look over the system. So this makes it very difficult. And again, blockchain is not a solution for everything. You really have to look for, why should I use a blockchain? Why should this product be on a blockchain? Maybe it's more efficient to have it on a traditional system, a database, or any other system. But still, there's a lot of opportunities, and there's, in my opinion, there's 4 feature sets or 4 topics that are really interesting to look at for a blockchain product. So this is the smart contract itself is very interesting because it automates a lot of things, and it can. I don't know. Have you talked about the smart contracts? What it actually does? So it's a computer code. So it simply says, if this happens, then do that. Okay. So it's very simple. But the great thing is that it can actually transact value. So you can say, if this happens, like an information comes in and it triggers a payment. So you could even have salaries paid based on solutions or whatever a person works on. So that's what a smart contract can do. The digital rights is a very similar or very obvious use case then. So if I produce music and you consume my music, then the smart contract can also control who's receiving the payments from that. And I can do an atomic transaction. So everyone that participated in creating the music, not just the musician, but also the people that did the sound recording and everyone, they can get a fraction of the payment. This is what can be done through smart contracts. Securities. We have a lot of things that can be secured through a smart contract, assets itself, or equity, everything like that. So that's interesting because ownership is much easier to transfer if I do it in a token. If I have shares in a company as a token, it's much easier to transfer. This has not been really built yet, but this is a concept that is being worked on in many cases. Then definitely a payment system, digital currency is something that blockchain is very useful for and is the initial use case for Bitcoin. So it was digital cash. And then record keeping is something that you can use to protect intellectual property, for example. So you can put something on a blockchain and say, I have a timestamp now of the information that I put onto the blockchain, and this can be a protection mechanism. I can simply show I've invented this before anyone else did because it's on the blockchain, and I cannot tamper with that information. Once it's in there, it's solid, rock solid, and I can show that I've actually put it in there because the private key belongs to me. I own the private key, so I can sign again on the same account to show that I actually did this transaction. Okay, so, but the web actually changed a bit to make this happen. So we talked about the internet before, and the internet has evolved a lot. So in the beginning it was 1989, as I said, that's when I would say the internet, sort of as we use it today, worked. It was mostly one way. Somebody presented something on the internet and I could read it, I could look at it. You know, this is the Web 1.0. Then the Web 2.0 was I could interact with it, I could even communicate, I could even generate content myself. You know, it's user-generated content, it was social media. Those are the things that happened in the Web 2.0. Then the Web 3.0 is where we're at right now. The Web 3.0 is transferring value over the internet. And I'm not talking about your online bank account. But I mean really through the internet, through the system itself, a digital value transferred from one person to another without any intermediary. And this is where the Web 3.0 comes into place. And I want to show you sort of how products will look like, or are looking like on the Web 3.0. So here is, we'll just look at the Web 2.0 transferring into the Web 3.0 because that's the recent step. So this is the broad overview. First of all, I go into more details. So there's like browsers. We have browsers that can work with the internet today, so you can open up any website. But these browsers are not capable of transferring value directly. They cannot interact with the blockchain directly. They always need an intermediary again to interact with that. I don't know if you've heard of MetaMask. Who's heard of MetaMask? Okay, very good. It's a lot. So MetaMask is a browser extension that you can use in Chrome to interact with the blockchain. It's a wallet, so to speak. It's a wallet you add to your Chrome browser. But the browser itself doesn't have that integrated. Now there's browsers like the Brave browser that have this now. So you can use a Brave browser to visit any website you want today, but you can also interact with the blockchain. You can also transfer value. You can pay, and you can use apps that have a cryptocurrency integrated. Storage is something that I will talk about later. Video and audio calls. There's some, I would say, decentralized services. You know, I'm a bit skeptical if they really use the blockchain, but that's fine. Operating system, the blockchain itself is an operating system as well. So every blockchain that also allows, for example, smart contracts is like an operating system. Then you have social networks that are being built. Steemit is the most successful right now. So you have blog posts that you can publish, and if people like your blogs, then you get a cryptocurrency paid for that. So that's quite interesting. So you can earn money without having any knowledge. You just write your stuff, and if people like it, then you receive cryptocurrency for that. Messaging is something I'll talk about later as well. Status has a browser or a mobile browser. And then offers like marketplaces like Remote Job. This is just one example of a marketplace. Athens is already working, and it's used a lot in the blockchain ecosystem to find developers. So you can go to Athens, given I need a JavaScript or a Solidity developer, and you will see like 10, 15 people drop up, and they all have their pricing in there, so you can interact with them. Well, let's go into more detail. So the first thing you do when you interact with the cryptocurrency, you have to acquire it somehow. If you don't earn it, you know, if your business is not already in the blockchain or on a blockchain space, and you earn it, then you have to buy it. So you have to exchange your fiat to crypto. And this can be done through, this is a very interesting chart because it also explains centralized and decentralized. So the left side is already, these are all, is there a pointer here? Sure.
Yeah,
So these here are exchanges that all work with cryptocurrency. They have like Bitcoin, they have all these cryptocurrencies. And they especially, what they're special in is that they exchange fiat to crypto. Do you know what the word fiat is common, or? As a currency? Do you know this nice joke that, you know, the crypto guys, the crypto nerds always say, one Lambo and one moon? Why do they talk about Lamborghini and not Ferrari? Because Ferrari is owned by Fiat. So, okay, so just quick joke. So these guys can all exchange fiat to cryptocurrency, okay? But they're centralized. I'll explain that in a minute, what centralized, decentralized, and that means. But these are all centralized exchanges. Now on the right side is already the new kids on the block, you know, and it's really kids on the block. It's decentralized exchanges. So there's no central point. There's no one I give money to, and then it's on their account. I always hold my own funds if I use decentralized exchanges. And I'll explain centralized and decentralized in a minute because it's really important. It's the most important thing you have to learn when you talk about or maintain your currency in a blockchain. But let's take one, let's take one, I thought I pushed a button. Take one exchange. This is Coinbase. Coinbase is the most successful crypto exchange in the world. They made $1 billion revenue in 2017. They have 200 employees. The New York Stock Exchange, everybody knows that. They have like $3.6 billion revenue. So more than 2 times or 3 times the amount. But they have like more than 3,000 employees. So Coinbase, by using this technology also for smart contracts and for maintaining the processes, already can use these efficiencies. And the revenue they generate is immense and has, I think, quadrupled over the last year or so. It's really exponential growth in that area. But let me talk about centralized and decentralized and even distributed. So when we talk about centralized, it means one source or one entity has the power to interact with us, or we interact with an entity. It's like the Facebooks of this world, it's every bank we use, and so forth. So actually, what we do is we give them something. We give them our money, we give them our data, we give them whatever values we have, we give to them. And they own this. We don't own it anymore. The money that we put on a bank account is not our money, because the bank can decide, like in Cyprus or in Greece, they can decide you can only redraw or draw 100 Swiss francs per day. You know, it's a decision they can make, and we cannot change that. So this is centralized. So an authority has the power over something that actually belongs to us. Then there's decentralized, and this is where the blockchain comes into play. Decentralized means that there are entities that are sort of nodes that run the whole blockchain. These entities, everyone can be one of these entities, but there's not everybody needs or wants to be one of these. So not everybody needs to be a miner or needs to run a full node. That's not necessary. So these are maybe you trust them or not, but you can switch to any one of them, and they verify the information that you give. But still, you own your own data, you own your values, your assets, the cryptocurrency you have, you own it. You don't give it to anyone. The distributed part is a very complex part, and it would be even more inefficient than a blockchain is today if we would use that, because that would mean everyone needs to be a full node, needs to be a miner, needs to verify every transaction that is on the blockchain. So that is not a system that really needs to be created in this way. So that's why we talk about decentralized and not distributed when we talk about the blockchain. So it's important to understand that even in the blockchain world, not every solution is decentralized. Coinbase is not decentralized. So what happens if I send money to the exchange called Coinbase, it's on their exchange, it's on their account. I don't own it anymore. So if anything happens to Coinbase, and they're not a bank or anything, so they're not protected, or I'm not protected at all. If they lose my money, like Mt. Gox did in 2014, if they lose that money, it's gone. And it's hard for me to sort of go against that. It's my money on a different account. Decentralized exchanges mean that they build the infrastructure for me to interact, for me to exchange my values, but I always have control over my own assets. This is a very complex topic, because then an order book, like somebody wants to sell and somebody wants to buy, gets more complex, because it's much easier to have the order book on one centralized server than distributed or decentralized. So but it's important to understand. So you should never leave too much of your cryptocurrency on a centralized exchange, like Coinbase. You should always move it back into your own account, and most likely have a cold wallet or hard wallet that you store your cryptocurrency in. The ratio is, if you have more cryptocurrency, then the hard wallet would cost like 2 times more than the hard wallet would cost. You should buy a hard wallet, because then you can protect your assets. Okay, let's go to the next part. Is wallets. So I talked about wallets right now, so that's a good point. So these are all wallets that you can download today, and there's some really nice ones, like, let me just go back here. There's one that's Jack's wallet is really nice because it works mobile and desktop. So the only problem that I personally have is any product that is offered through an app store, to me is again sort of under the power of a centralized entity, because Apple or Android can still decide we won't have this app in our app store, we will not release an update or whatever. It's under their control. So sometimes you have the discrepancy between the desktop version, which you can download directly from their website, works much better than the app version. So that's something you also have to consider. But maybe I'm too much into decentralization already. But here's a good example of a wallet that you can use only on your desktop or on your laptop, on your computer. It's not mobile, it doesn't have a mobile version. You can compare it to your bank account. So you can access your funds that you have. You can see how much tokens do I have. I can transfer them to another account. It's like my bank account, like my online banking. The interesting thing here is, though, again, you own the assets. So if there's another service called My Ether Wallet, for example, you can use the same account, the same information in any of these wallets. These are just user interfaces. they only give you the a nice interface to access your money. So it would be like if I have an account with UBS and now decide, oh, I don't like this interface, I want to use the Credit Suisse login or online banking. Then it's not possible today, but this is sort of the way they work. So I could imagine if I could put the money I have, I could also access this through the Credit Suisse account. And even though I have a bank account with UBS. So this is the way like my crypto, for example, works. It's just the user interface, it just gives you access to your funds in an easy way. But I still own the funds myself. So this is a very good service that you should look at. Or JAX, as I explained before, these services here. That, actually, you can, if you look up this guy, Matteo Giampiero Sago, I didn't create those charts. He does that. He does it many times. He has created like a very big chart just recently showing what the ecosystem looks like. So you can look him up on LinkedIn. He's posting there. It was very interesting, very good stuff. Then Messenger and browser. We talked about the Chrome browser and that you need a different browser for accessing Web3 components, the blockchain components. So right now you have here, like you have messaging a lot, but it is a very interesting browser, mobile browser that allows you to message and access any application that is running on the blockchain. It's the website you can go to today. You can go to status.im, and it's working already. They're still in a I'm not sure if they're in an alpha phase or in a beta phase. So, but you can look at that, and in there you have a lot of products that you can use on your mobile phone with this browser. So it's a browser as well, and a messaging app. So it's like WeChat even. It's even more than WeChat than like WhatsApp. I don't know if you know WeChat. Come on. But this is where they will evolve into anyways. It's more a multifunctional browser messaging system. So it's very interesting. Then social networks. We talked about social networks before. So Instagram, Facebook, Twitter. Who's using Twitter? Okay. Not all of you. Wow. Okay. And Facebook? Anybody deleted Facebook after the Cambridge Analytica? Wow. There's a few people here. Very good. Okay. Because I'm always saying, and I'm very skeptical about using blockchain in developed countries like Switzerland. To me, there's no use or no need for decentralized products in countries like Switzerland. So it's really something that you don't have to use here because it's very convenient to use, and we don't care if our data is being abused. No, I'm not, it's nothing harmful, but it's just the truth. We don't care too much if our data is abused or not. We have a legal system that works and everything. But there's countries that could use something like PPAT. PPAT, you can also use it today, is Twitter on the blockchain. And it's censorship resistant. So in China, for example, if I live in China, then my tweets could be censored. They could be deleted, Twitter has to do it then. And in this system, it's not possible. So you cannot delete any tweets. So you can use that as a Twitter alternative if you want to. And your data is owned by you. It's not owned by anyone else. So it's people. Let me just see if I can give you the websites as well, because you can actually use them. So it's peepf.com. You can look it up. So pick up your phone and use it. Marketplaces, interesting topic. That's where my startup is active in. So like the eBays, Amazons, and everything. But a marketplace actually is any place where two people interact and do commerce. And this is where Swarm City is the project I'm working with. So we could replace Airbnb, for example, or we could replace Uber. So what we built is just the infrastructure. We built like a WordPress for blockchain. So you can build your own marketplace. Like if you want to create a dog walking marketplace, you think you're the best one that knows exactly how the user interface should look like, then you can create this on Swarm.city with the features that we already provide. The only thing you need to do is create your own user interfaces, like a website. You create your own website, JavaScript, HTML. That's the knowledge you need to have. You don't have to understand the blockchain itself. So you can just interact with the APIs that we have, and you can build your own marketplace. And it's a peer-to-peer marketplace that you can create. So it's always just the two parties interacting. So if you look at Airbnb, it's somebody has an apartment, Airbnb sort of rents it out for him, or he puts it on a platform that's called Airbnb, and somebody else uses the platform. But Airbnb says what are the rules to do this, to place the apartment on there. Or Uber. Uber is an even worse example, because Uber dictates the price even of how much the driver can earn. So the driver cannot even say, I need like 20 euros for a ride, because Uber will say, no, you can only earn 15 because we want to have the passenger. We want to undermine the taxi service. So, and this cannot happen in Swarm City because it's only infrastructure. People can use the contracts that we created, the business models we created, and can interact with that.
And is that already available then?
It's we have like a beta version available on the Swarm.city. You can register, you can create an account, you can create deals. It's very simple to create deals because you simply say, what do I need? You put in a request for any topic. So it's not a specific user interface yet, but once we are fully built, by the end of the year, we have the infrastructure ready so that other people can build their marketplace on top of it.
Imagine I'm a taxi driver. Now, if an Uber can come in and easily, essentially, bump me off, but as a taxi driver, what do I have to do on Swarm City to get myself started up?
You register and you promote yourself. You promote yourself to passengers. So there's somebody owns the marketplace. So somebody creates like the Uber. Uber, let's say he creates Uber on Swarm City. So he creates a map. He creates the fields that you have to put in, the pictures maybe of your car, maybe some information on you as a driver. And then they will promote it as well in the region. Maybe it's a Zurich or Zug or Geneva marketplace only. And you as a driver can participate in that. And either there's enough passengers already, or you have to promote your service. And that's what Uber and Lyft drivers do anyways. They sort of use one service and then promote the other service to passengers and sort of try an onboarding as they use the other service. So
is there at least one taxi driver on the Uber equivalent of Swarm City?
Well, right now it's a generic user interface.
Okay.
So you can offer your.
Okay.
Actually, it's the other way around. It's requesting. So I would request, I need a ride, and that's when people would sort of look at it and accept it. But it's not specifically done for Uber or for rideshare right now.
Yeah.
So it's early, very early. Insurance, interesting topic as well, because it can be very much automated. A lot of things in insurance can be automated. So EtherRisk, they started with a flight delay service, and it's available today. So you can go to etherrisk.com, and you can, if you fly to city, you can put in your flight number and give them an allocation of money. And you say, if my flight is delayed, and this is a general rule that applies to any flight you have actually, you can receive money for any delays, any cancellations. But EtherRisk makes it very easy because you do this once for this flight, and if the flight is delayed, and that's what it's called an oracle, so there's a database that gives you information if the flight is really delayed. And this information comes to the blockchain. That's what an oracle is. The information gets into the blockchain and it triggers the payment automatically. So if you have a 15-minute delay, you don't have to do anything anymore. You know, in today's system, if you use AXA has a service like that, or any flight, any airline has these services, but you have to send in your ticket. You have to explain which flight you were on, why was it delayed, maybe even. So you have to give them information. You have to send it in. You have to wait for them to come back, and so on. Here it's just you send in the money, you send in the cryptocurrency, and if it's delayed, it's an automatic payout. And it's quick, it's not 3 days payment or time or anything. So you can use that as well. Identity is a very interesting topic, but I think the solutions today, and this is one of the solutions that is being used in Schaffhausen, and there's one in Zug as well. It's called U-Port, but this one is in Schaffhausen. Switzerland actually has 2 projects trying to solve the identity problem, or the put identity on blockchain. I think they're both not my preference of the solution. I think they're just copying what is existing and putting it on a blockchain, but I think technology always has the opportunity to rethink what is the problem and how can I solve this problem with a new technology, not how can I use the new technology to replace the process or to replicate the process I already have. So this is replicating the process we have, which is very common and will be used because everybody will know how to use it. But I think it's not using the technology right. So just my thought. Data storage is something you can do, but it's not on the blockchain. It's on a separate redundant server. It's called IPFS. So it has very ambitious goals. It's called interplanetary file system. Wow. Not just the world. Yeah. So you can store data there today. And Swarm City, for example, we use it to store data because we don't want to have any servers involved. We don't want to hold data. But also the user shouldn't hold data on his phone or on his client, so to speak, because it needs too much bandwidth and storage at the end. So we use IPFS to store the avatar picture, the name of the user, and other information. And IPFS is something that is also encrypted. So every information I can encrypt with my own password. So nobody else than myself can recover that information. Computation is, I think, one of the last slides I have is Golem. You can use Golem to use processing power. Again, this is not processing power on the blockchain itself. You can sort of connect your computer to Golem, and the processing power of your computer can be used, the one that you're not using right now. Or if you have like servers that are not used, large companies have servers that are just available for peak times, and then they're not used the other time around. They can rent out this computer, this processing power. And Golem makes this possible. They have, again, this smart contract that makes the payment systems, that integrates the payment systems, and therefore makes it very easy to interact. And every time you use processing power, it could be micropayments. You can use just very fractional computational power. It gets rewarded, or you have to pay for it, or the other way around. If you rent out your computer, then you get rewarded. IoT, Internet of Things, IOTA is a very special blockchain. It's not, actually it's not based on blocks, but it would go too far also from my knowledge side to explain this. But it's a very good, this is very much more efficient for small devices to interact, and it's still secure. And it's being used, for your light bulb to communicate with, or your refrigerator, whatever things will happen in the future that need to communicate and need to transfer values. So this is the overview that Matteo created. So this is, I don't even think I picked out all of them, so I just picked out randomly. Some of them are not even finished or are not products that you can fully use. Most of them are like beta version or MVPs. As I said, we're very early stage, but it's interesting to see this, and maybe 90% of them will fail, because that's what also happens with startups. Maybe only 10% will succeed, but even those that fail will learn a lot from failing. So that's going to be interesting. And if you're interested in what's happening in Zug or in Switzerland, actually, because it's a map of Switzerland that the Crypto Valley Association is maintaining. It's called cryptovalley.directory. You can see all the startups in Switzerland. So this is very interesting to see. Not all of them have full products yet, but this is the ecosystem that is evolving in Switzerland. And if you imagine that this is like, I think Switzerland has like 450 startups today. 4 years ago it was maybe 2. And so it's been less. I think even 2 years ago it was 20. So it's growing exponentially, and you can see that the ecosystem itself will benefit as well. Like startups that have started raising money last year, like Status that I showed as a browser, they're incubating now. So they're using part of the money to foster the ecosystem. And so this will grow and grow exponentially, because the more successful these projects are, the more they will foster the ecosystem again. So this is very good. And then I'm done. You can reach me on these contacts. Feel free to contact me if you have any questions or any remarks, comments, whatever. And I'm happy to answer any questions if we have any time.